Hi, I'm Ed Marzell, President and CEO of Connexus, and today I'd like to talk to you about reducing costs of turnaround by optimizing the way you perform SIS testing. When turnarounds happen, a lot of money is spent due to business interruption, and a lot of money is also spent on tools and personnel to perform testing. And if you optimize the way this testing is performed, a lot of money can be saved. Turnarounds and shutdowns are expensive, and they're also variable cost. Understanding how you perform a turnaround and planning it ahead of time is crucial to minimizing this cost. In a lot of cases, planning starts 1 to 2 years in advance of the turnaround. If there's a major capital project, it may start even sooner than that. A 30-day turnaround could cost as much as $30 million and use up to 1,500 contractors. In addition, there are lost opportunity costs of $1 to $3 million per day. That's lost revenue from not being able to perform the process plant's normal activity. In order to set manageable goals, you need to do things a year in advance. And the amount of time that is spent in the turnaround can be significantly cut because SIS testing is often a critical path item in the turnaround that happens during the later stages of the turnaround. SIS testing often cannot be performed during the core part of the turnaround because a lot of the equipment that needs to be tested is locked out or tagged out. As a result, there's a lot of intense pressure on the SIS testing team to speed things up because they are the last item that needs to be taken care of before the plant can be restarted and production resumes. There are a lot of options for reducing the cost of SIS testing. These include performing partial tests offline. Things like sensors can be tested while the plant is still in operation, and if that portion of the testing is done offline, money can be saved. You can remove unnecessary testing steps, things that are not safety critical. It's important to only test the core logic during the turnaround as opposed to testing all potential functionality. In terms of final elements, it's only necessary to test them once, while many test procedures would have final elements such as valves and rotating equipment motor starters turned on and off many times during the testing process. Also, you should extend the turnaround duration as long as possible. Using instrumentation as the limiting factor in the test interval is generally not prudent. You should be looking at major equipment items. And in some cases, it's even possible to extend the turnaround duration or the testing duration for a particular piece of equipment to be multiple intervals of the turnaround. So if a turnaround happens once every 2 years, maybe there are some instruments you only need to test every 4 or 6 years, so you don't need to test them at every turnaround. SIS standards allow for the testing of safety instrumented functions either end-to-end or in parts. And in a lot of industries like offshore oil production, testing in parts is the preferred choice. The reason it's preferred is that it gives you a lot of operational flexibility because there are a lot of equipment items that can be tested while the plant is still in operation, preventing a major disruption to processes. Because the partial testing can be done while the plant is in operation using bypass mechanisms, time during the turnaround, the core turnaround, can be saved. All sensors generally can be tested while the plant is offline, limiting the amount of testing that you need to do during that crucial turnaround interval. While the plant is shut down, outputs can be simulated via communicator or logic. And also, this moves the amount of time for calibration, inspection, and testing out of the core shutdown window. Much of the testing that is done in an initial site acceptance test of an SIS is not necessary to be repeated during every turnaround. So there are a lot of unnecessary steps that are routinely performed that can be left out in order to save time and make that crucial shutdown window smaller. This would include things like testing of bypasses, which is not required. Also, if you have complex voting schemes like 2 out of 3, testing every possible combination of that 2 out of 3 vote is not necessary to ensure that all of the instruments are operating properly. Also, if you have complex fault handling options, in addition to bypassing options, every one of those configurations does not need to be tested during the turnaround. Also, when considering valves, tight shutoff is very rarely a requirement of the safety instrumented function. Now, a tight shutoff valve may have been selected for a wide variety of reasons, but the requirement for a tight shutoff in order to achieve a safe state with respect to the safety function is very rare. As a result, doing elaborate measured leak testing is usually not necessary as part of the SIS testing. In addition, rebuilding of valves in order to achieve a class 6 or a bubble tight shutoff is usually not necessary. And the amount of time saved and money saved by not pulling those valves out, sending them to be rebuilt, or even do the elaborate leak rate measurement testing can often be foregone, speeding up the turnaround immensely. It's very common for an SIS to perform a lot of functions that are not core to the action of safety instrumented functions. Safety instrumented systems have a lot of additional alarms and additional actions that occur as a result of safety functions, but aren't necessarily safety critical. In a lot of cases, you're going to move valves to known positions to allow startups to occur in a more controlled and known fashion. And you'll also stop a lot of pumps and compressors in order to minimize utility usage and also to prevent fluid from flowing around while the plant's in a shutdown state. But in many cases, these actions are not core to what the safety instrumented function does. Those are not the actions that allow the plant to achieve a safe state with respect to the specific hazard that the SIS is designed to mitigate. So when you're performing your core turnaround testing, it's really only necessary to test those core safety instrumented function actions that allow a safe state to be achieved. Other actions that are not core are only really necessary during initial commissioning, or potentially they might be required after a major modification to the logic has occurred. But if logic has not been changed, it's generally not necessary to test them at every turnaround. A lot of effort could be saved if key instruments are only tested once or twice, and usually we're looking at the final elements. Consider a typical compressor. It might have a high level shutdown on the knockout drum, high vibration shutdown, axial thrust shutdown, discharge pressure shutdown, discharge temperature shutdown. There are a lot of measurements that will cause the motor starter to be de-energized. But do you need to test every one of those pathways? Well, the answer is no. Again, unless a major logic modification has occurred, what you really want to test is the end instrument or the motor starter's ability to go to a safe state. So you'll only need to do that once. And consider a hydrocracker that might have over 200 input measurements that are going to cause the recycle gas compressor to shut down. Doing that many tests or moving the final element that time actually could damage the equipment that you're trying to protect. So when you're performing your core logic testing, going through the setup process to reset the logic to cause that final element to go to its operational state, and then commanding the final element to move back to the shutdown state with associated measurements to make sure that it was able to do it in its process safety time, is only required to be done once or twice. It does not need to be done for every sensor that causes it to move to the safe state. Once the instrument has been tested the once or twice, from that point in time on, it's sufficient to simply make sure logically or electrically that a signal to go to the safe state has been generated, but actually moving the device is not necessary. And that saves time not only in the movement of the devices, but also in the bypassing and the resetting that's required to move it into its normal operational state. As a corollary to the information on the previous slide, it's important to remember to only test final elements with the core equipment. So if you're looking at a motor starter of a compressor, you're going to want to make sure that you test the pathways in that compressor system that caused the motor starter to be de-energized. But often there are a lot of non-safety critical reasons to stop that compressor. Again, if you want to move the plant to a known state to allow easier reset and restart of the plant, you're going to want to stop pumps, you're going to want to stop compressors, but a lot of times stopping them is not safety critical with respect to the hazard that initiated the shutdown in the first place. So testing all of the different sensors that might cause a pump or a compressor to stop or a isolation valve to close is not always necessary. It's only necessary if they're safety critical. So only test them in their core equipment groups. You can also take this optimization process as an opportunity to extend test durations to the longest degree possible. You're going to want to max out your PFD limit with respect to your SIL verification calculations. Of course, you don't want to make too many drastic moves at once. We would only recommend increasing your turnaround test interval by 1 year at a time, even if your calculations show you can extend it much more than that. The reason for that is that the failure rate of your equipment items is a function of how frequently you exercise them, how frequently you test them, and how frequently you maintain them. So a dramatic increase in test interval might negatively impact the failure rate and somewhat invalidate your calculations. But ultimately, when you're determining your turnaround interval, you're going to want to think about other pieces of equipment other than the SIS. Items like large compressors and large pump systems, reactor systems that need catalyst changes, those are the things that should really be driving the turnaround interval as opposed to the SIS design, which is much more easily modified and potentially allow extension through use of redundancy and better diagnostics, better components. It's also important to remember that you can test different subsystems of your SIS at different intervals. There's no requirement for them to all be tested at the same time. In a lot of cases, turnarounds can be skipped for some components. Logic solvers, especially if they're SIL 3 certified, have very low PFDs at very long test intervals. So if changes aren't performed to the logic, you can go a long time in between tests of logic solvers. It's possible that if you have short turnaround intervals, like 1 or 2 years, that in some turnarounds you might only need to test the valves or the final element subsystems. In some cases, sensors might not need to be tested but every other turnaround, and a complete logic test testing the functionality of the logic solver might only be required every second or third turnaround. So don't test all of the components unless you have to. Having different test intervals for different components allows you to really focus on where the problems are, where the highest probability of failure is, to minimize your testing and, again, reduce efforts and apply those resources elsewhere. There are substantial benefits to optimizing your SIS testing. We at Conexus have helped many companies optimize their testing process by rewriting their test plans, reperforming calculations. And what we've seen is that with an optimized testing process, the amount of labor required to perform the test is reduced by 20 to 30% over a comprehensive testing process. This also reduces the amount of test equipment that's necessary and decreases unnecessary activity and unnecessary personnel. The most exciting part, though, is the decrease in the amount of time that's required to perform the plants while the plant is shut down. And that's crucial because that plant shutdown time could cost $1 to $3 million a day. So we've found that we can reduce that downtime by 50 to 75%. So if you can reduce your turnaround by 2 or 3 days, that could be anywhere from $2 to $9 million in savings, simply by changing the way you do your testing. I hope that you found the material in the presentation to be informative and serve as a guideline to help you to optimize your SIS testing and save substantially on the testing process. We at Conexus would be more than happy to help in this process. Conexus provides myriad services related to SIS, including performing the SIL calculations that would be required to optimize your test intervals, making recommendations on test intervals and different timings for the different components. We can help write test plans or rewrite test plans so that they take advantage of the optimization process. We've done this for many customers around the world and have had great success, and we look forward to helping you. So please feel free to contact us at Conexus. You can see our website at www.conexus.com, or you can send an email referring to this presentation to info@conexus.com. Again, I'm Ed Marzell, President and CEO of Conexus, and I look forward to talking with you soon.